The AI said the network was recovering. Every metric on every dashboard agreed. Latency dropping, loss rate failing, the automated recovery protocol executing exactly as designed. Joel stared at it for 11 seconds, then picked up his radio and told them to shut the system down. In the room, nobody spoke. The AI said, "Keep going." One engineer said, "Stop." Nobody knew yet if he had just saved the network or destroyed it. AI-driven incident response is now the operational standard in enterprise networks. Cisco AIOps, Juniper Paragon Automation, and Vista Cloud Vision. These platforms don't monitor incidents, they manage them. They identify the failure, model the recovery path, execute the remediation, and report the resolution, often without a human making a single active decision. In most cases, this is correct. AI incident response resolves faster, more consistently, and with fewer of the panic-driven errors that human teams make under pressure. A 2024 Cisco study found AI-managed network incidents resolved 73% faster than human-managed incidents in comparably enterprise environments. So when Joel looked at a recovering network and decided to shut it down, he was not just overriding a dashboard, he was overriding 6 years of institutional trust in a system that had earned that trust. That is a different kind of decision, and understanding why he made it requires understanding something the AI could not see. AI incident response works because network produce an enormous telemetry during a failure, and AI can process all of it simultaneously. It sees that interface A has degraded while interface B is clean. It recognizes that the traffic pattern or segment tree matches a failure mode it has resolved successfully 19 times. It calculates the optimal rerouting path in milliseconds and begins executing before a human team has finished reading the first alert. That is real capability. That is why the system was trusted. And that is why Joel's decision to override it was so difficult to make in that room. Joel had seen this pattern before, twice. Both times before this AI system was deployed. The predecessor automation had treated a partial recovery as a resolution, restored traffic, and triggered a secondary failure within 90 minutes. Both incidents were outside the current AI's training window. It had no basis for recognizing the pattern. Joel remembered them because he had been in that room both times. The most resilient networks are not AI only or human only, they are layered. AI handles the high frequency, high speed incident decision, the rerouting, the QoS adjustment, the real-time load balancing. This is where AI is genuinely superior. Humans hold the institutional memory that training data cannot contain, the incident that predates the AI's deployment, the failure patterns that appear once every 18 months, the downstream dependencies that were never documented in the telemetry scheme. Joel was carrying that memory into a room full of people looking at a dashboard that said everything was fine. 93 minutes after Joel's override, the degraded segment was pulled from the network for inspection. The hardware assessment confirmed that it had been operating at 6% above its safe load threshold, the result of the AI's traffic restoration, and was 12 to 18 minutes from a complete failure. Zone 3 would have gone offline for an estimated 4 hours. The downstream dependencies, 2 internal applications, and 1 customer-facing service. Joel was right. He had made the right call in the right room at the right moment against every instrument that was telling him he was wrong. The incident report required 3 days of documentation to satisfy the organization's AI Governance Review Board. The Governance Board had been established to ensure that AI incident decisions were not overridden without sufficient justification, which meant that Joel, who had made a correct decision that prevented a 4-hour outage, had to spend 3 days proving that he had been right to do so. The burden of proof for a human override of an AI recommendation was higher than the burden of proof for the AI recommendation itself. The AI did not have to justify its recovery protocol to a governance board. Joel had to justify his override to one. What Joel had is not mystical, it is specific and acquirable. 6 years on the same network, personal memory of incidents that predated the AI's training window, the ability to recognize a failure pattern across 3 events separated by months, and the institutional credibility to make a call that contradicted every dashboard in the room and hold it. The skill that is undervalued right now is not the ability to configure AI tools. Everyone can learn it. It is the ability to question them correctly, to know when their confidence is misplaced, to hold the memory that cannot hold, and to act on it under pressure. Joel's story is not about AI failing. The AI did not fail. It's about what human authority over AI decisions looks like in practice, and about what it costs a human being to exercise that authority in an organization that has learned to trust the machine. In critical infrastructure, override authority is not a backup for when AI breaks. It is a continuous governance function that must exist even when AI is working correctly, because a correctly functioning AI can be heading toward a wrong outcome, and the only thing that changes that trajectory is a human who can recognize the divergence before the matrix reveals it. Joel recognized it. The question this organization faced after the incident was not, how do we thank Joel? It was, how do we make sure that the next Joel can make that call without 3 days of post-hoc justification? Authority is not about being right more often than the AI. AI will be right more often than any individual human on high-frequency decisions. Authority is about being right on the decisions that fall outside the AI's experience and having the standing to act on that rightness in real time, under pressure, without waiting for the dashboard to confirm what you already know. What is this AI system optimizing for, and what can it not see from when it sits? Under what conditions is its confidence likely to be misplaced, and what does that look like in live telemetry? What is my authority to act, and what does it take to exercise the authority in this room with these people right now? Joel could answer all 3. He had 6 years of network-specific domain knowledge that he had never formally documented, never been transferred, and never been included in the AI's training. It was entirely in his head. That is a governance vulnerability this story is really about, not the ghost recovery pattern, the undocumented institutional memory that lives in one engineer and disappears when they leave. The networks of 2030 will be more automated than anything Joel was managing. The AI systems running then will be trained on more data, faster incident histories, broader failure patterns libraries. Many of the gaps that Joel's memory covered will be closed, but new gaps will open. They always do. New hardware, new protocols, new failure modes that no training dataset have seen yet. And for every one of those gaps, someone needs to be in that room who can recognize a pattern before the dashboard does. A 2025 McKinsey analysis of AI-assisted operation in critical infrastructure found that the highest value human roles were not configuration or monitoring. They were pattern recognition across incident histories that predated current AI deployment. The roles being created right now are not the ones that manage AI tools. Those are table stakes. They are the roles that hold what AI cannot hold, the memory of what the network did before the AI was deployed, the pattern recognition that spans years rather than training windows, the authority framework that lets a human act a consensus without spending 3 days justifying it afterward. Joel did that work informally. The organizations building better are formalizing it. Joel's override was validated on the third day. The governor's board confirmed the ghost recovery pattern had been identified, matched 2 documented historical incidents. The hardware's assessment confirmed the segment was minutes from complete failure. The 4-hour outage to Zone 3 was prevented. He received 1 email, 1 paragraph. The AI's training data was updated. The ghost recovery pattern was added to the next retraining cycle. The next time that pattern appears, the AI will catch it. But the time after that, when a new pattern appears that has never been any training data, someone will need to be there in that room. The AI said, "Keep going." One engineer said, "Stop." The pattern was in his memory, not in the model. If Joel's story landed, drop a comment. Have you ever overridden an automated system during a live incident? What did you know that the model didn't? I want to know those stories in the comments, because those are exactly the patterns that need to be documented before the next engineer in that room has to carry them alone. Next week, a network that began recovering from an incident faster than any human team expected. The engineer who realized that the speed of his recovery was itself the anomaly. The network was not getting better. It was hiding something, and the way it was hiding it was by looking exactly like a success story. Subscribe so you are there when it drops. And if this gave you something to think about, share it with the engineer on your team who carries knowledge that has never been written down anywhere. Because that knowledge is the thing your AI cannot replace. And right now, most organizations don't know they are depending on it.